Good morning, you guys. Got on here to work out some of these problems so that if you have questions on how to do one of these problems, you can fast forward to the problem. I'm going to try to make these short videos, short and to the point, so hopefully I'll explain enough about the problems to where you know what I did to get there. Okay, number one, which of the following is true? And they're talking about, is it arithmetic or geometric? So arithmetic is when the same thing is added or subtracted each time. And on this one I see that we are subtracting 7 each time. So yes, that is true. And the common difference there would be a -7, subtracting 7. This, we're taking half of each term, so we're multiplying by 1/2. So yes, that is geometric. And the common ratio would be 1/2. This is not geometric. We're not multiplying by the same thing each time. These are all of the square numbers. So this would be 1 squared, 2 squared, 3 squared, 4 squared. That would be not geometric. If I were writing an a sub n formula for that, I would write that as n squared. Not geometric, not arithmetic. It's just a different series. So the only two that are true are 1 and 2. So the answer there would be C. Okay, next one. Which of the following sequences is arithmetic with a common difference of 3? So we want to add 3 every time. In this one we're subtracting 3, so the common difference here would be a -3. Here we're multiplying by 3, so this is geo, where r is 3. Here we're adding 3, so this is arithmetic, and the common difference is 3. This, is this arithmetic? Yeah, it's arithmetic if the common difference is 0. Is it geometric? Yes, it is geometric if you make the common ratio 1. Alright? So as an a sub n formula, I would just call that a sub n is equal to 3 because every term is 3. So this is a good example of you can be both arithmetic and geometric. But the answer to this question would be C. That is the arithmetic with a common difference of 3. Alrighty. This, they're asking for the explicit formula. So I notice that this is arithmetic. The common difference, we are subtracting 6 each time. So the common difference is -6. If the common difference is -6, then I know that there is a -6n in the formula. Okay? To get to 5, though, for the first term, when n is 1, we have to be at 5. And to get, when n is 1, we would have to add 11 to get to 5 for the very first term. So that is the explicit formula. -6n plus 11, so D would be the answer there. Number 4. They give us a sequence and they say, what is the 100th term? The 100th term. So let's see. I noticed that this is the same one that we had above. This is arithmetic with a common difference of -6, right? So we just went through the process of finding the a sub n formula, which would be the first step here. We would find the a sub n formula, the explicit formula, and then we will plug in 100 for n. We'll have -6 times 100 plus 11. That is -600 plus 11, which is -589. So B is the correct answer there. Alrighty. Number 5. The sequence given by this is geometric with what common ratio? What is the common ratio? Well, it's very easy to look and see. It is whatever is being raised to the n power or n minus 1. As long as this is an n plus or minus some number, that is your common ratio. So the common ratio is 1/3. Easy peasy. Alright, the 5th term of this sequence is what? What is the 5th term? Well, all I have to do is plug in 5 for n. So wherever there's an n, I'm going to plug in 5. So we'll have 8 times 1/2 to the 4th, which is 8 times 1 to the 4th over 2 to the 4th. So that is 1/2, B. Alrighty. What is the sum of this series? Alright, well, I notice that this is an infinite series, and it is geometric with common ratio 1/3. Therefore, we can use our formula that says the sum of an infinite geometric series with r between -1 and 1 is equal to the first term, I'll call that a, over 1 minus r. A is the first term, r is the common ratio. So we need to take our time and get a, the first term. The first term is when n is 1, because of that 1 right there. So I put 1 in for that n right there. So I'll have 4 times 1/3 to the 0 power. 1/3 to the 0 power is 1. 1 times 4 is 4. So the very first term is 4. I like to fix these this way. I'm going to multiply top and bottom by a 3. The top is 12, and the bottom, don't forget to distribute to each of these terms. We get 3 minus 1, so that is 12 over 2, or 6. So the sum of that series is 6. Okay, let's write this sequence. Actually, that's a typo. This should say series. We need to correct that because it is a series. A series is a sum or difference of terms. Okay, so let's write this series using sigma notation. Okay, let's see what's going on in this. It's not arithmetic. Is it geometric? 21, if I take any term, is it? Wait a second. Is it arithmetic? Oh, it is arithmetic. I didn't see it immediately, but we are subtracting 15 from each term to get to the next term. Yep, that's going to work. So it is arithmetic with common difference -15. So I'm going to write the explicit formula, -15n. What do I need to add to -15 to get my first term of 36? Well, I'll need to add 36 plus 15, so I need to add 51 to that, right? When n is 1, -15 plus 51 would get me the 36, I think. Is that right? Yes, that's right. Okay, so that's my explicit formula, and now I just need to write it in sigma notation. So n, we were starting at n is 1. How many terms were there? There were 6 terms, so we put a 6 up there, and that is the sigma notation for that series. I need to remember to fix that for next year's worksheet. Okay, I think I'm going to keep on going. This has only been 8 minutes, so I'm going to keep on going. I don't want these videos to get too long, but we'll keep on going a little bit longer. Okay, write this sequence in sigma notation. Okay, this, and by the way, there is no way that that one could have been geometric. There's no way it could have been geometric, because you would never have positives and negatives but not alternating in sign. Okay, like this one. This one is alternating in sign, so it might be geometric. And it is because if I multiply by a -2, if I multiply by a -2, and if I keep on multiplying by a -2, we get to another term. So this is geo with r is equal to -2. So the explicit formula will have a -2 to an n power. But for geo, it's easiest if you make that not just a plain n power, an n minus 1 power. If that's the case, then you can just write the very first term here, and you've got your explicit formula. That will work for everyone. And now we just put summation on it. We are starting n at 1. And how many terms did we have? 1, 2, 3, 4, 5, 6, 7. We had 7 terms. So that would be the sigma notation for that series. This is also a series. Okay, number 10. Okay, the sum of, I have my phone in front of me, and Siri just thought I was talking to her when I said series, but I'm not. Okay, the sum of the first 30 terms, the sum of the first 30 terms of the arithmetic series. Hang on, I gotta take a brief. Alrighty, had to reach down and pet. I'm taking care of my daughter's little bunny, and whenever he wants to be petted, he'll come and put his little sweet paws on my feet, and so then I come and pet him. So anyway, I will be doing that occasionally. Alrighty, the sum of the first 30 terms of the arithmetic sequence with first term 2 and 30th term 102 is what? So the first 30 terms. So I think arithmetic sum formula. The arithmetic sum formula starts with n. And then we multiply by the average of the first and the last terms. The first and the last terms. So I'll write that as the first and the last, maybe last as the subscript, over 2. So our formula will be 30 is n. The first term is 2, the last term is 102, and then we're averaging those, so we divide it by 2. So this will be 30 times 104 over 2, which is 30 times 52. That'll be a 0, and then 3 times 52 is 6, and a 15, so 1560. B is that answer. Alrighty, the sum of the first n terms of the arithmetic sequence series with first term negative 20 and nth term 50 is given to be 120. So the sum is 120. What is the value of n? So we're using that formula for the sum of an arithmetic series again. We're looking for n. The first term is negative 20. The last term is 50, and they tell us that that is 120. So we're going to solve this equation for n. Negative 20 plus 50 is 30. N divided, or 30 divided by 2 is 15. You know what I think I would do instead of dividing that and making it 15? Then I would have to divide 120 by 15. I think I'm going to multiply that 2 over and make it 30n is equal to 240. This will be much easier to divide. We're dividing by the 30 now, and we get 8. 8 terms. Alright, which of the following can be used to find the sum of the first 10 terms of a geometric series with common ratio negative 3 and first term 2? So now we're doing the sum of a finite geometric series, and we have a formula for that. The sum of a finite geoseries is, we start with the first term. I'm going to call the first term a. And then we have a fraction, and both the top and the bottom have 1 minus r. That's how I remember it. But the top r gets an n power. Okay? So the first term, the first term is 2. The common ratio is negative 3, and we have 10 terms. So I know that's the formula. Apparently it simplifies to one of these. So let's clean it up. We'll have 2 times 1 minus, if I raise a negative to the 10th power, it's just a positive. So this will just be 3 to the 10th divided by 4. 1 minus a negative 3 is 4. So this is, we can reduce these, and we get 1 minus 3 to the 10th over 2. 1 minus 3 to the 10th over 2 is C. Be careful choosing those answers. Alrighty, next up, what is the sum of the first 6 terms of the geoseries with first term negative 2 and common ratio positive 2? So again, we have the formula for a finite geoseries that was up here, right? So, alrighty, I'm back. Okay, so we're using this formula. So we start with the first term. The first term is -2. 1 minus r to the n, so the common ratio is 2 to the n is 6 over 1 minus r. So there's the formula. So we just have to clean it up. So let's see, we're going to have -2 times 1 minus 2 to the 6th. 2 to the 6th is, I know 2 to the 5th is 32, so 2 to the 6th is 64, over a -1. I'm going to make that a +2, right? +2 times a -63. So -126a. Okay, find the sum of this infinite series. It's an infinite series because it does not stop. See the ... does not stop. So this is geo with r equal to, what are we doing from every term to get to the next one? We're multiplying by 1/5, right? It's geo with r 1/5 and first term 5. First term is 5. There's a short formula for the sum of an infinite geoseries. It's the first term over 1 minus r. That is the infinite sum. So the first term here is 5. R is 1 over 5. So once again, I'm going to clean this up by multiplying top and bottom by 5. And I get 25 on top. Don't forget to distribute. 5 minus 1 on the bottom, 25 over 4. C.